Hello and welcome. In this video, you'll learn how to read barcodes with MVTec HALCON. Let's have a look at a basic example. Here we read an image with an EAN13 barcode. First, we need to create the barcode model. The resulting handle can be used to modify model parameters, read barcodes, and access results of the barcode search. Then we use Find Barcode to find and read barcode symbols in the given image. As output, we get the decoded data strings and the symbol regions. With these two lines, we can read the barcode successfully. The HDevelop example defect EAN13.HDev shows some impressive results with the default parameters. However, there are many possibilities to adapt the barcode algorithm to increase robustness, reduce runtime, or find even more challenging barcodes. Let's have a look at the parameter code type in Find Barcode. By default, with Auto, all available barcode types are decoded, except MSI and pharmacode. Alternatively, you can specify a tuple with the barcode types you want to decode. You can also exclude barcode types with a tilde. We recommend limiting the decoded barcodes as much as possible to avoid false detections and optimize runtime. Before having a look at more advanced parameters, let's first understand how the barcode reader works behind the scenes. Basically, there are two steps. First, barcode candidates are located in the image. Then, the operator tries to decode those candidates. For each successfully decoded candidate, the symbol region and the decoded string are returned. If you can easily provide the region where the barcode is located, you can use Decode Barcode Rectangle 2 instead of Find Barcode. Thus, you can skip the potentially time-consuming candidate search. With getBarcodeObject, you can access objects that were created during the last Find Barcode call. For example, you can retrieve all candidate regions. Here you can see some candidates that are obviously not barcodes. Let's adapt our barcode model to ignore those candidates from the start. With the operator setBarcodeParam, you can adapt the model parameters. Here we can set the barcode width min to 100 pixels. When checking the candidates again, we can see that only the relevant barcode region is returned. For your application, this approach can increase both speed and robustness. Another interesting aspect of the decoding process are the scanlines. To access these intermediate results, you have to activate the persistence mode. To do this, we again use setBarcodeParam. Note that this increases the required memory. Now, these XLDs represent the scan lines and detected bars of the candidate region. The HDevelop example InspectScanlines.HDev nicely visualizes the candidate region, the extracted scan lines, the valid scan lines, and scan lines and edges that were merged to read the barcode. Per default, the parameter mergeScanlines is set to true. Thus, partially occluded barcodes can be read. The parameter can be deactivated for performance reasons. By default, a barcode is considered decoded with the first successfully decoded scanline for most barcode types. If you get false detections, it can help to increase min-identical scanlines. Let's have a look at an example image. Here, a second barcode is detected. We can fix this by setting min-identical scanlines to 2. Now only the correct barcode is returned. Note that you can also access these intermediate results by inspecting the barcode handle. Here you can find a lot of information that can help to quickly check the status of the barcode reader. If you are trying to decode barcodes in low-resolution images, have a look at the example barcode small elements robustness.HDev. By default, the width of the narrowest bars is expected to be a minimum of 2 pixels. With an up-to-date HALCON version, it's possible to read barcodes with bars that are smaller than 1 pixel. You can also retrieve information about the read barcodes with Get Barcode Result. Thus, you can, for example, perform a print quality inspection. In particular, we support the standard ISO 15416. Here, I set Candidate Handle to 0 to retrieve the results of the first barcode candidate. For meaningful print quality inspection values, please refer to the ISO standard, in particular, the chapters regarding the image acquisition requirements. Lastly, I'll give you some quick tips on how you can further improve the barcode reader for your application. Among many other things, the standards call for a quiet zone to be located next to the barcodes. HALCON, by default, can decode barcodes that violate that quiet zone requirement. To avoid false detections, you can adapt this parameter. If your barcodes are always oriented in a certain way, you can adapt the barcode reader accordingly. This can improve both speed and robustness. Reducing the domain of the image is, as usual, a good way to improve speed and robustness as well. You can train the parameters of the barcode reader based on one or multiple sample images. The operator setBarcodeParam_specific can be used to set parameters for individual code types. Thus, you can use one barcode handle to find different code types with specialized parameter settings. This concludes this tutorial. Have a look at the operator reference and the provided HDevelop examples for much more information on the topic. Thank you for watching.